What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. In this video, we're going to go over some static routing. So this is going to be our very first lab, and it's going to be very simple, okay? So for our paid viewers, again, this lab is available to you. For our non-paid viewers, you can check out our EVNG videos to see how to build and create EVNG topologies. And of course, our Git lab has all the solutions and it has all the instructions for every lab we do in this course. So there should be a link in the description below if you're watching on YouTube, or if you're on our paid course, there should be a link as well on your course page. So I'm going to bring these lab instructions over to the right, and then I'm going to go ahead and start our lab. So step 1 is turn on all devices, which I've already done. And then step 2 is going to be paste baseline from GitLab. So for you guys not in our paid course, our free GitLab is going to have router and switch baselines that you can paste into your devices to make the housekeeping commands real easy. And since I've already done that, let's now go into our routers and switches here. We're going to console in, and my native console is going to be Secure CRT. And if you're not using Secure CRT, here is your chance to change that. Please use a good terminal emulation program like Secure CRT instead of the old-fashioned like PuTTY. So now we're going to do step 3. Verify all IP addressing is correct and that the LAN is configured correctly. So over here on R1, our sub interfaces are good to go. Now let's check out R2. Let's check out our IP addressing as well. So yep, we're going to be good to go there. And as you can see, we're using a /31 on our point-to-point link here, which is possible and which is what you should do on these point-to-point links when using public IP addresses. Okay, and then let's just check to make sure that our LAN is good. So we're going to log into our switch here and verify our trunk is created. We're going to verify that our VLANs are created and assigned correctly. Okay, they are. And we're going to do that on switch 4 as well. Log in, username Cisco. Password is also Cisco. Our trunk is created. And now let's check our VLANs, make sure they're assigned and created correctly. And yes, they are. So now let's dive into the technology that we're here for, which is static routing. So step 4, configure a static route from R1 to R2 to reach all of R2's networks. So what we're going to do here is create 2 static routes. So from R1 to R2, we need to be able to reach this network, 172.16.20 and 172.16.10. So from R1's perspective, we need to say, okay, I need to reach those networks. I'm going to reach them by using this exit interface. So let's go ahead and do that. So that syntax is going to be IP route, the destination network, and we're going to use the network address and the prefix length or subnet mask. And then we have a couple options. We can use the exit interface, or we can do the next hop IP. We're going to do the next hop IP for this one, which is .1, right? Because we're .0, our neighbor's .1. And then for the other network we need to reach on R2's LAN, we'll go ahead and do the exit interface, ETH00. And we're going to see if we can reach both of these, okay? And now we need to do the same thing on R2. So on R2, we're going to route traffic for the destination we want to reach, which is 192.168.10.0/24. And we can use our exit interface. And then we're going to do the exact same thing, except now let's go ahead and put our exit interface and also our next hop IP address, which is going to be .0, because the next hop for R2 is going to be router 1's IP address on that point-to-point link, which is .0. Let's go ahead and hit enter. Now step 6, let's verify our static routes. I'm going to show you guys how we can look at it in our running configuration by using this regular expression here, section and IP route. We can see both our IP routes here. Let's go ahead and do that on R1. Boom, and we're good to go. Now let's go ahead and check our routing table. So if we look at our routing table here, we can see that this router is going to have all of its local and connected routes here, of course, right? We can see the codes up here, local and connected. That means it's what the router already knows about, right? Every interface that's connected to it and that has an IP address or a network assigned to it. And then we have our S code up here, which stands for static. So we can see our static route here. We can see the administrative distance, and we can also see the metric here, which is just a 0, right? And we can see how we reach that network via 75.0.0.1. And then we see this one here, which is a little different. This is saying it's directly connected via Ethernet 00. So since we use the exit interface, essentially what this is saying is that this network belongs on that interface, which we know it not to be true, but that's okay because we're going to forward the traffic, anything destined for that traffic out 00 anyways. And when it reaches the next hop of R2, R2 actually does have these network local to it, and it's going to route the traffic accordingly. So let's go ahead and do the same thing on R2. With this time, we're just going to do show IP route static. Just look at the static routes. And again, we have the same thing here. But for this one, we did the next hop IP and the exit interface. And now you can see here we have the next hop and that exit interface. So pretty cool. Now let's do some ping tests. And again, remember, as a network administrator, we like to test things from the network. So from R2, let's go ahead and ping the destination networks. And let's go ahead and make sure that our own LAN can reach it by sourcing it out eth0/1.10. That's going to be the sub interface here for our VLAN 10. So now we know our own users on VLAN 10 and 20 can reach the users over in VLAN 10. Let's also try it for 2.0. Great success and great success. So this test right here is really all we need, guys. I mean, a ping or an ICMP protocol, right? A ping message, you need full reachability. So we know the static routes on R1 are configured correctly and that we configure correctly here on R2. And we know that our networks can reach each other because we source our pings like good network administrators. And we know that our users can reach. Awesome. So that's going to be it for this lab. And you kind of see how just easy a static route really is. It's simple in its nature. I mean, you put yourself in the perspective of R1. You need to know about these networks. So you tell it, hey, R1, route to this network via this exit interface or next hop. And it's as simple as that. In our next lab, we're going to get a little bit more complicated though. We're going to add in a few more routers. We're going to do maybe some load balancing, right? We're going to do some floating static routes and a host route. So stay tuned for that as we get into even more of a deep dive of our static routing. Thank you.